Yes, Assalamualaikum warahmatullah and very good morning. So I will explain or present the solution for the test one uh, for communication system course. Okay, let's see the question number one. So the question number one, given the receiver system that have two amplifier and one filter with the input given 7.55 milliwatt and all the gain, there are three gains for two amplifiers and one filter. So with the absolute power gain, no unitless. So AP1 75, AP2 1.5, AP3 is 100. So so here you can see that the filter they have some gain. So this is the when implement into the system there are some leakage or the gain come from the circuit internal itself. So they have some gain for the filter, which in a single filter there should be no gain, right? So the question asks to calculate the input power in dBm, total gain, and output power in watts and dBm. So this to solve this question is just straightforward. Follow the equation. So the input power in dBm is 10 log input power in watt divided by 1 milliwatt. So because the unit is dBm, we need to divide by 1 milliwatt. So we get 8.78 dBm. And then the total gain. So the total gain is we just multiply all the gain, unitless gain. So this is already 75 times 1.5 times 100. So we get 11250 unitless total gain. And then the output power is just multiply the gain with the input 11250 multiplied by we have input here is 7.55 milliwatt. So we get 84.94. So this in watt. So the question also asks in dBm. So in dBm we just straightforward apply the equation. So P out 10 log P out divided by 1 milliwatt. So we substitute P out is 84.94 here. So we get 549.29 dBm. So when you answer this kind of question, all the value need to put the unit, okay? In final exam, no unit, no mark will be given. Okay, very straightforward. You will get all 4 marks. So question number 2, you are given in a communication system, the signal power 24 milliwatt and the noise power is 0.5 milliwatt. So you need to calculate SNR, signal to noise ratio, in both linear, unit, decibel, dB form. And also you are asked to explain is based on the SNR value, is it what is the potential impact on the quality of the communication system? So by apply the SNR equation, signal power divided by signal noise, sorry, this signal noise, noise power. So the signal power divided by noise power is 5. This is this is this 5, right? 5. Okay, 5 milliwatt divided by 0.5 milliwatt, so we get 10. So signal to noise ratio is 10. This is unitless, and then this dB is 10 log 10 is 1. So don't forget the unit. So from this equation, we know that the signal to noise ratio is 10. 10 meaning that the signal is 10 times stronger than the noise, right? With this divide. So that means that signal is very strong. That's result in a good communication quality. So mean, or another way around, it can improve the communication system. Then you get 6 mark. So question number 2. So you are given radar system that have antenna with a cable loss 1.2 noise figure. So both losses and noise figure is given by all this antenna, RF amplifier, and then mixer, and then IF amplifier. So there are four component or four circuit in this receiver, radar receiver, and the losses and the noise figure is given. So the question is evaluate the noise figure of the overall receiver system and whether it is in acceptable range or not, and justify your answer. So we need to calculate all the overall system and then justify the range, is it accepted or not, and give the reason. So we apply the equation to calculate gain and also noise figure. So just apply this equation for antenna, RF amplifier, mixer, and IF amplifier. So we know that losses should be negative. If positive is gain, right? So negative losses. So we need, don't forget negative here. So just apply into this equation, we get the value. Similar with RF amplifier and mixer. Mixer also losses, so don't forget negative here. Divide by 10, 10 the power of negative 6 divided by 10, we get this value. Similar with IF amplifier, so the gain 56, so we get this value. And next we need to calculate for noise figure using this equation. Noise figure is given for all the circuit. So we substitute into this equation, then we get the value. So after we get the value, so we need to calculate the total noise, the total overall noise figure. So the total noise is using this equation. So we just substitute the value that we get from this table. So we get 9.326. So 9.326 is 1 mark. 9.326. So this table, if you correct all, you get 5 marks. So up to this value, all 1 mark. And then when you convert to dB, 10 log F is 9.7 dB, you get another 1 mark. So based on this range, you make the justification that this acceptable noise figure because the value is between 2 to 10 dB. So this will contribute about 2 marks. So I think the question is not really difficult. Just straightforward, apply the equation. So you need to understand what exactly question required, and also you need to do some sort of analysis. So the total mark is 20 for test 1. So that's all for the discussion of the test 1 solution. So all the best and thank you.